Okay, Bismillahirrahmanirrahim. Let's continue our discussions on the threads in this series of lectures. Last time we spoke about the critical sections when we have two or more threads, and if they both access a critical section like this variable x, then there is this possibility that the variable will be updated by one thread, let's say thread number 2, and thread number 2 may exit the critical section, or may exit the CPU, may finish executing in the CPU before it actually updates the value of x. Then thread number 1 will come in, and thread number 1 will update x, and therefore three increments of x by t1, then by t2, then by t1 will end up with the value of x equals 2 instead of 3. That's what we talked about last time in our previous lecture. So let's see how this can be solved. In general, critical sections are solved by operating systems or by all types of advanced features of programming languages through several tools. Let me write some of them on the side here. Something called for critical section control. Actually, I mentioned there is something called mutual exclusion. Mutual exclusion means thread 1, this thread 1 will exclude thread 2 from entering the critical section. Thread 2 will exclude means prevent thread 1 from entering the critical section while thread 2 is inside the critical section. So mutual exclusion can be implemented using different tools, such as they are called semaphores. Semaphores, this is a term in operating system used. They can use locks. Locks means each thread will be given a lock or a flag. So if thread 1 goes into critical section, certain critical section, it will take the lock and no one can enter the critical section. Whenever it leaves the critical section, it will release the lock, so thread number 2 can get in. There is another tool called monitors. Monitors, this is a small piece of program that sits outside the critical section. Every thread that wants to enter the critical section has to be permitted by the monitor. And if the monitor sees that thread 1 or thread 2 is abusing its right into the critical section, then monitor can do something about it. And there are other methods. Let's not get into that. Let's go into how Java resolves this problem. In Java, we use a class which is built within the Java called synchronized. Synchronized this. This means this current thread. Now thread 1 is executing. When I say synchronized this, it means that this thread 1 is being synchronized, meaning that if thread 1 goes in the critical section, which is the critical section here, which is about the printing the name of the thread, which thread is inside, which has entered the chat room. So there is a chat room, and we'll say a new user, for example, and this new user, and then there is a name, has entered the chat room. That's my critical section here. So this whole thing will be synchronized. Thread 2 will again use the same technology called synchronized. So this will be thread 1 and thread 2 will mutually exclude each other from entering the critical section. So if we use synchronized, then we can guarantee that the critical section will be used by one and only one thread at a time. So this is what we mean by the word or synchronized. This is statement. All synchronized statements exclude mutually. Note this word, exclude mutually. Mutual exclusion. This allows mutual exclusion to be implemented in Java. So when a thread enters this space, the synchronized this statement, it verifies first that any other synchronized this statement is not being executed by another thread. So this is the meaning here. When, like for example, when thread 1 wants to execute synchronized, once you arrive at this position, synchronize this. So synchronized thread, the Java language and environment will make sure that no other thread is using this critical section, this part of the system, and then it allows thread 1 to execute. If it happens that another thread 2 is currently in the critical section, then thread 1 will not be able to execute. Note that in this schema here, thread 1 has come within the section 4. It starts executing. It finished this portion, so it got out of the critical section. So now thread 2 synchronize this can enter. It can go in the critical section. Now, if thread 2 does not finish here, it's still within this area, and thread 1 wants to come in, it will not be able to do so. That's the idea of mutual exclusion. So if such a statement is being executed by a thread, such a statement here, it refers to synchronize this. If it's being executed by a thread, then this thread, as well as all other threads trying to execute synchronize the statement, are forced to wait. Note, are forced to wait until the thread executing the synchronize this terminates the statement. What this means, let me put it in drawing here. One of my shapes, this is my shape. So this is the synchronized statement, and okay. So let's say this statement is being executed by thread 1. Let's put it here. So this is thread 1 is executing. And let's say when executing this area here, assume that I am entering a critical section. Let me put, there is a critical section here. This is my critical section. Now this could be anything, could be I am updating any type of variable, let's say x plus plus. So here I am executing this guy. Now for some reason I want thread 2. Okay, let's take this guy. Here's thread 2. And thread 3. These guys, they want to enter the critical section, but they will not be able to do so. Okay, let's see. Okay, now this guy, and let me make sure that we see this guy as a block. So I will visualize thread 2 and thread 3 are being blocked. You cannot enter the critical section while T1 is executing. Let's say if T1 now finishes, let's say T1 is done. So let me take it out. Okay. So T1 is done. This is how I represent the fact that T1 is done. Let me take it out here. So now T2 or T3, whichever has higher priority, and the priority means it has precedence. If T1 is T2 has higher priority than T3, then this block will be moved away and this guy will enter the critical section and T3 will remain blocked. So now if T2 is done, so let me take T2 out from here, then T3 will be allowed to enter as well. So this is how the synchronized works. Now here all of this assume that T2 is synchronized. I should not forget this, and T3 is also synchronized and T1 was synchronized. If all of them are synchronized using the statement synchronized this like this, then of course we have okay. So if all of them are executing the synchronized statements, then this is exactly what happens. So when a thread enters the synchronized this statement, as I said, it verifies that first no one else is inside this region, then it can enter. If such a statement is being executed by thread 3 currently, then T1 and T2 will be waiting outside the critical section, and waiting outside, this is a queue, and we are not building the queue. This is being built by the synchronized class. All right. So when the thread executing a synchronized this statement, it leaves the critical section. That is when it terminates the synchronized statement, as I showed here. That means I terminated the synchronized statement, which is within this region here. Once this happens, then a thread waiting for a critical section enters its synchronized this portion or area, whether it's T2 or 3. When a thread now enters the synchronized this, it blocks all other threads from entering their synchronized statement. This is how I visualize the word block. That's my blocking here thing. I was blocking this guy and I am blocking T3 if T1 was inside the critical section. If it was here, if T1 was executing the critical section, then T2 and T3 will be blocked. That's exactly what I mean by this statement right here. Okay, continuing with the synchronized class, putting all critical sections in synchronized statements, we are guaranteed that the chat server, if we are doing the chat server, will execute correctly without raising null pointer exceptions caused by concurrent execution of other critical sections. Now this is an example here. We are saying that assume the critical section. Let me if I have a chat room, let me show what I mean by a chat room again. This is my chat room here. Let me take this and empty this room. It's my chat room, and this chat room let's say it can have a maximum of 5 people chatting together at any point of time. So I will have T1, let's put this in black. So I have T1, T2, T3, T4, T5. So I can have 5 threads chatting to each thread represents, of course, a client. They are chatting together. Now, if I have 6 threads, I will not allow one more thread to go into this chat room. So in order to do that, I would have a counter. So a counter here. Let me do this counter like this now. Okay. So this is my counter. So this counter, every time a thread comes in, the counter, in this case, it will be 5. So once the counter equals 5, then all other threads will not be allowed. So there is a possibility that I will have 6 threads with my counter equal 5. So every time I get into the chat room, I increment this counter. So that, which means a thread enters, and if the thread leaves, I will decrement the counter. So the counter equal 5 now. Let's say if 5 leaves, let's take this 5 out, then this counter will become 4. Okay, now then again I have one more counter, 5 comes back, then the counter is 5. So assuming in my case I have thread 1 comes in. Now let me take all of these threads out. I have thread 1 comes in, so this is 1. Then I have thread 2 comes in, so this counter equals 2. Now let's say thread 3 comes in, and as I did with the critical section with the x incrementing of x, counter remains 2. I failed to update it because of the critical section synchronization problem. Now I have T4 comes in. Oops, why did I do that? Okay. Now I have T4, and this is counter 3. I have T5. Let's say things go all right. So I have 5 threads, and then I have T6, and this is counter 5. Note that my counter says I am 5. I have 5 threads, but indeed I have 6 threads. So there is a violation. So let's say if the chat room can handle only 5 persons at the same time, then I have 6 while my counter says 5. So there is a problem here. So that's why what we mean by here, we are guaranteed that the chat server will execute correctly without raising the null pointer. Let's say if the number 6 here, okay, now I have T6, so there are 6 counters, and because I have 6 clients in the chat room, so this will raise in this case a null pointer, which means there is a problem. So let's do it this way. Okay, this will be my null pointer. Okay, so that's what will happen in this case. Although it should not be the case, I shouldn't have this problem, but I will because I have exceeded my capacity with 1 pointer. That's how the problem with synchronization, which we have mentioned now. Synchronization, when I synchronize threads, I resolve the problem of mutual exclusion, but I create one more potential problem called deadlock. Incorrect use of synchronized, note the word incorrect, which means I'm using synchronization, but for some reason there is some error. It can cause deadlocks of the program, and I will explain what I mean by deadlock. A deadlock is a scenario when one thread waits for another thread to leave its critical section forever, which means one is inside the critical section, the other one is waiting, and the first one does not exit, and the second one waits forever. How does this look like? Let's show it in visual. This is my critical section. Okay, and I will show my thread now in different way. I will show my thread. This is my thread, thread 1, and this thread 1 is, let me put it this way now. Note I reversed my arrow. I made the arrow pointing from critical section to the thread 1, meaning that thread 1 is currently being allocated the time to execute the critical section. Now, thread 2 here, this thread 2 is actually waiting for this critical section to be available. I will represent it this way. So thread 2 is waiting for critical section 2, for the critical section, and the thread 1 is currently using the critical section. So just with this critical section alone, let me do the following. Assume that while thread 1 is executing the critical section, thread 1 is executing the following type of code. This is thread 1. It's executing while true, these are several statements, and this is the end of the while true. Now while true means infinite loop. This is what how do I do that now? I want to put this in okay. So this is the statement executed by, so T1 now is executing this statement, or this piece of code. It's in the critical section. It was given the time to execute, and within the critical section, it's while true. It keeps rotating forever. It will never end here. So T2 will be waiting for the critical section, which will never be allocated, which will never be free, because T1 never terminates. Now, worse yet, if T1 gets killed while it's in the critical section and you don't have garbage collection, you do not collect the garbage and you do not get the critical section back to the memory, and you do not delete all the things which were allocated by T1, then T2 will never be able to get to the critical section. There is another form which is a complete cycle. Let me show that in a different slide here. Okay, I will do a new slide. This is the slide here I will show. This is critical section. In parentheses, I would say this is a resource. I have another one, critical section resource 2. This is resource 1. Now resource 1 could be a critical section like a printer. This could be a memory location, could be a variable, could be anything. Let me show now the threads in, this is thread 1. This is thread 2. And I will use this type of notation. Thread 1 is asking, this arrow means it's asking for, put this here. So thread 1 is asking for critical section, and this critical section is being used by thread 2. And let me put this in different color to show that it has been allocated. It's not giving you any, actually I will put it in green. All right, make that in green. So this is allocated to thread 2, and thread 2 is asking for critical section 2, and critical section 2 has been allocated for okay. So this is a loop, this is a cycle. Thread 1 is using critical section resource 2, and while it's doing that, for it to complete, it requires this guy, a second resource. Let's say a printer, or a memory, or a USB drive, or a driver, or any class within the system. But this class is being used by T2, and T2 will not release it until it gets resource number 2. So this cycle, it shows a deadlock. Now, because T2 is using this as a critical section while it is, and it's using synchronized. Let me use the word synchronized here. So I'm using critical section 2 under the term synchronized. Synchronize this. I am synchronizing this guy, so no one can use a critical section of resource 2. So poor T1 will not be able to get in here. And also, I am synchronizing this one. No one can enter the this section. T2 cannot enter this section because it's being synchronized by T1. So this synchronized and this synchronized, they mutually exclude each other's. T2 excludes T1 from getting into resource 2, and T1 excludes T2 from getting into resource 1. So that's why. Okay, to illustrate this case, the case which I just talked about the deadlock, let me show this piece of code. Let's say thread 1, thread 2, and I'm using the same chat room example. Okay. Here, this is synchronize this, thread 1. Note the statement while true, and this while true is executing this guy here. So this is the loop. So this loop will never end. So when the thread 1, I execute synchronize this, which means block any thread from entering this critical section, and I enter a while loop. I will never be, until of course I execute the word quit here. If I don't use quit, I will continue to reading forever, read line, read line, read line, read line, and break, read line. If, of course, if I get the quit, I do a break. If I don't get the quit, I keep within this loop. Now, so thread 2, assuming that the time is over after 6 time units here, this thread 1 stop executing. Now thread 2 wants to execute. It says synchronize this. This is in red. So I will not be able to enter this guy. I will not be able to enter this for integer I equal 0, etc. to update the number of clients in the chat room. So this red block will be synchronized and will block thread 2 from entering the critical section. Why? Because thread 1 is executing a while loop. This while true, until and unless someone hits the quit button, it will execute forever. So this portion of code in red will never be executed by thread 2. Why? Because thread 1 has entered a while true loop which stays forever. That's exactly what we mean by this statement. All right, I will stop right here, and next time I will talk about the thread methods. What are the methods which we use for threads like start, run, set name, interrupt, priority? There are many threads, many methods. I will stop, talk about few of them which are very important for our purpose. And for today, I will stop right here, and I will continue and resume next time. Thank you.